x squared minus 7x plus 12 is equals to 0, right? So we are supposed to solve for x, right? So if we try and factorize this, we're going to get x, and then on another bracket, we also have x being equals to 0. The right question to ask yourself at this point is, which two numbers do I multiply and get 12? And then when I add them, I get minus 7, right? That is minus 4 and minus 3. So we're going to get x minus 4, x minus 3 being equals to 0. So it is easy to see from this point that x is equals to 4 or x is equals to 3. And just like that, you have scored yourself 3 marks. And then the following question, 1.1.2, we have x multiplied by 3x plus 5 being equals to 1. We're supposed to solve for x correct to 2 decimal places. As soon as you see 2 decimal places, at this point you should know that you're supposed to use the quadratic formula, right? So let's go ahead and try writing this in standard format. So if we solve the left hand side, we're going to get 3x squared plus 5x is equals to 1. We take 1 to the other side to get 3x squared plus 5x minus 1 is equals to 0, right? We know that we cannot factorize this. So let's just go ahead and paste the quadratic formula. X is equals to minus b plus or minus the square root of b squared minus 4ac, everything divided by 2a, right? So if we go ahead and substitute, so this constant here, 3 is a, 5 is b, and minus 1 is c, right? So that we on the same page. And then if we substitute, we're going to get, in place of minus b, we have minus 5, and then plus or minus b squared. So we're going to have 5 squared minus 4ac. A is 3 and c is minus 1. Everything divided by 2a. A is 3, right? So we have x, and then x will be equals to, so one value you're going to get 0.18, and the other value you're going to get x being equals to minus 1.85. And just like that, we've solved for x using the quadratic formula. Let's see if we can do 1.13, right? It looks a bit more interesting. So for 1.13, we have x squared, which is less than minus 2x plus 15. Let's take minus 2x plus 15 to the left hand side and see what we get. We're going to have x squared plus 2x minus 15 being less than 0. What can we do now? Critical values. We need our critical values, right? So to find our critical values, we're going to say x squared plus 2x minus 15 is equals to 0. Again, we're going to open two brackets. We're going to open two brackets and ask ourselves that key question again. Which two numbers do I multiply and get minus 15? But when I add them, I get plus 2. That is plus 5 and minus 3. So we're going to get x plus 5, x minus 3. So x is equals to minus 5 or x is equals to 3, right? So let me propose something to you. What if I say x is between minus 5 and 3? Is this the case? We cannot just conclude that that holds, right? We have to actually test it out and see if our inequality is going to be maintained. So a number between minus 5 and 3, let's go ahead and take 1, right? So let's not forget that we started with x squared being less than minus 2x plus 15. So if we take 1, we're going to get 1 squared on the left hand side, right? So that is 1, which is supposed to be less than minus 2 multiplied by 1 plus 15. So we have 1 being less than, so we have minus 2 plus 15, that should be 13, right? And then indeed 13 is greater than 1. So this is actually our answer. This is what we're looking for. But what were you gonna do if we took a number between -5 and 3, and then our inequality was not maintained, what were you gonna do next? What was gonna be our solution? You need to watch the other videos I've done on solve for x to know what to do in such cases, because this right here, this is not always the case, right? Some people think that it is always like that, but I'm telling you, it is not. You need to actually check that out. And then 1.1.4, we have the square root of 2 multiplied by 1 minus x being equals to x minus 1. So it's easy to see here that we can square both sides to get rid of the square root, right? So we're going to get 2 multiplied by 1 minus x being equals to x squared minus 2x plus 1, right? So we squared here, and then on the left hand side, we're going to get 2 minus 2x being equals to x squared minus 2x plus 1. Right, so if we take minus 2x to the right hand side, it is going to be plus 2x, right? And then if we take 2 to the right hand side, it's going to be minus 2, right? And then ultimately, we're going to get x squared minus 1 being equals to 0. So x squared is equals to 1. So x is equals to 1, or x is equals to minus 1, right? So every time when you start with the square root and you square both sides, right, you're probably going to have an answer which is not necessarily true for the original equation you started with. So we actually have to go and check whether x is equals to 1 is actually a solution to the equation we started with. And then we check also for x is equals to minus 1 to see if it's actually a solution for what we started with. So let's go ahead and do that. We have the square root of 2, 1 minus x being equals to x minus 1. So when x is equals to 1, what are we going to get? We're going to get the square root of, so we're going to have 1 minus 1. So we just get 0, right? Being equals to 0 essentially. So 0 is equals to 0. So when x is equals to 1, there's no issues arising. What about when x is equals to minus 1? Let's see. We're going to have 2 multiplied by 1 minus x. So that is 2 multiplied by 1 plus 1. Basically 2, right? And then we're going to have minus 1 minus 1. So here on the left hand side, we're going to have the square root of 4 being equals to minus 2, right? So you can see that this doesn't hold. So our answer here is only supposed to be x is equals to 1, right? And then 1.2. So for 1.2, we're supposed to solve for x and y simultaneously. And then we're given 3 to the x plus y is equals to 27, and x squared plus y squared is equals to 17. Let's see if we can manipulate these first before moving to the second equation. So it's easy to see that we can write these as 3 to the x plus y being equals to 3 to the power 3. So x plus y is equals to 3, right? So what can we do? We're told that x squared plus y squared is equals to 17. Let's try squaring both sides and see what we're going to end up with. If we do that, if we square both sides, we're going to have x squared plus 2xy plus y squared being equals to 9. Right. And then we can have x squared plus y squared plus 2xy being equals to 9. We know that x squared plus y squared is equals to 17, right? So let's sub that in there. So we're going to have 17 plus 2xy being equals to 9. 2xy should be equals to 9 minus 17. So that should be minus 8. Right. So that is what we have there. So 2xy is equals to minus 8, right? But we know that x plus y is supposed to be equals to 3. So if we make y the subject of the formula, we can say that y is equals to 3 minus x, right? So let's substitute this back into this equation. If we do that, we're going to get 2, and then x is x, so x is x, and then y is 3 minus x, and then this is all equals to minus 8. 6x minus 2x squared is equals to minus 8, right? Now let's take minus 8 to the left hand side. We're going to get 6x minus 2x squared plus 8 being equals to 0, right? And then if we divide everything by minus 2, we're going to get minus 3x plus x squared minus 4 being equals to 0, right? So we can write this nicely as x squared minus 3x minus 4 is equals to 0, right? So now what are we looking for? We are looking for two numbers that when we multiply, we get minus 4. When we add them, we get minus 3, right? So that is minus 4 and plus 1. So we have x plus 1, x minus 4. So x can be equals to minus 1, or x can be equals to 4. But what is y when x is equals to minus 1? We know that y is equals to 3 minus x. 3 minus x. So when x is equals to minus 1, y should be equals to, so that is 3 minus 1, y should be equals to 4. And then when x is equals to 4, y is equals to 3 minus x. So y is equals to 3 minus 4, y should be equals to minus 1. Right, so that is 1.2. If you want to see the solution for 1.3, click this video in the screen right now. Let's look at 1.3. Determine without the use of calculator the value of whatever this is. Right. We have a series. What is a series? A series is a summation of the terms on a sequence, right? So you can see that for the first term, we have 1 divided by square root of 1 plus square root of 2, right? So that is the first term. And then the second term, we have 1 divided by square root of 2 plus square root of 3. And then the third term, as you can see, is 1 divided by the square root of 3 plus the square root of 4. So when I looked at this problem, I'm like, okay, fine. I can see the trend. I see what is going on here. We have Tn is equals to 1 divided by square root of n plus square root of n plus 1, right? So I have the general formula for the terms of this series, right? So all I need to do now is to calculate the sum, and then I have the answer to 1.3. The question says that we must determine without the use of a calculator the value of that series that we're given there, right? So in order to determine the sum, I need to know which sequence it is. Is it arithmetic? Is it geometric? Or is it quadratic, right? It has to be one between the three under normal circumstances. And if that is the case, I can easily go ahead and solve the problem. So if it is arithmetic, then we must have a common difference. But then when I try computing the common difference, I cannot get a common difference. So it is not arithmetic, right? And then the next thing I tried is to find a common ratio. If it is geometric, we must have a common ratio. And then the same is true. When I divide T2 by T1, it is not equals to T3 divided by T2. We don't have a common ratio. And lastly, quadratic, the second difference must be constant. But when I actually compute that, the second difference is not a constant. So it is not one of the three, right? That process probably took me like 3 minutes. And then what came after that took me about an hour to solve a question that is just out of 3 marks. So ultimately, you have to realize that you have to rationalize the terms of this series. What do I mean by that? So let's look at T1, for instance. T1 is equals to 1 divided by square root of 1 plus square root of 2. So if we want to rationalize this fraction, we have to multiply it by the conjugate, right? So we multiply it by square root of 1 minus square root of 2 divided by square root of 1 minus square root of 2, right? Because that is just equals to 1. So we basically multiplying by 1. But then now our answer is going to be rational, right? So if we compute that, you're going to get T1 being equals to square root of 1 minus square root of 2 divided by, now I want you to see something. So we have square root of 1 plus square root of 2 multiplied by square root of 1 minus square root of 2. So that is a difference of 2 squares, right? So we're going to have 1 minus 2 in the denominator, right? And then we're going to get square root of 1 minus square root of 2 divided by minus 1. If you compute that, you're going to get minus square root of 1 plus square root of 2. So this is T1, right? Let's go ahead and do the same for T2. So if you do the same for T2, we have 1 divided by square root of 2 plus square root of 3. And then again, we are multiplying by the conjugate, right? To get square root of 2 minus square root of 3 divided by square root of 2 minus square root of 3. On the numerator, we're going to get square root of 2 minus square root of 3 divided by 2 minus 3, right? So our answer here will be minus square root of 2 plus square root of 3. So that is T2, right? So let's just do the same for T3 and the last term. We don't have to do that for all the terms. It will take forever. So if we do that for T3, we're going to get 1 divided by square root of 3 plus square root of 4. You already know what we're going to do from here, right? But then ultimately, our answer will be minus square root of 3 plus square root of 4. That will be our final answer after we do all that we've been doing, multiplying by the conjugate and so on. So that is T1, T2, and T3. Now we just need the last term, right? Now we just need the last term, which is actually T99, because we can see here we have 99. So it will be T99. So if we do the same thing we've been doing for T99, we're going to have 1 divided by square root of 99 plus square root of 100. And then this will give us minus square root of 99 plus square root of 100. Right, so now we have our terms rationalized. Let's write our series again, but then now we're using the rationalized terms, right? So if we do that for T1, we have, what do we have for T1? We have minus square root of 1 plus square root of 2, right? But minus square root of 1 is just minus 1, right? So we have minus 1 plus square root of 2. That is the first term, right? Plus the second term. So let's go ahead and add the second term. For the second term, we have minus square root of 2 plus square root of 3, right? And then the third term, we're going to have plus what? Plus minus square root of 3 plus square root of 4. Right, so that is the third term. And then plus all the terms in the middle until the last term. So for the last term, we have minus square root of 99 plus square root of 100. And now we're just one step away from getting our answer. So we have minus 1 here. And then here we have plus square root of 100. Those two numbers will remain as they are. But then all the numbers between those two numbers, they're gonna cancel out. Let me show you how. Here we have plus square root of 2, and here we have minus square root of 2. And then here we have plus square root of 3, here we have minus square root of 3. Here we have plus square root of 4. So on the term that comes after this one, we're going to have minus square root of 4. right? Whatever you have is going to be subtracted by the term that follows. The only terms that are going to remain is minus 1 and plus square root of 100, right? There is no plus 1 that is going to cancel out the minus 1. And there is no minus square root of 100 that is going to cancel out plus square root of 100. All these terms will be equals to minus 1 plus square root of 100, right? All the terms in the middle are going to cancel out. And that is just minus 1 plus square root of 100, which is 10, right? So the answer to 1.3 without using a calculator is 9. How do you know whether a geometric series is convergent or divergent? If a geometric series is convergent, then the ratio should be between 1 and minus 1. That is how we're going to answer 2.1.1. The question is saying that, is this a convergent geometric series? Justify your answer with the necessary calculations. Right? We have our series right here. The first term is 1 divided by 5. The second term, 1 divided by 15. And then the third term, 1 divided by 45. So in order to find the common ratio, we say T2 divided by T1. You can also say T3 divided by T2. That will also work. So let's see what we get when we say T2 divided by T1. This will be equals to, so T2, 1 divided by 15. And then everything divided by T1, which is 1 divided by 5. This is equals to 1 divided by 3. And then as we all know, 1 divided by 3 is between minus 1 and 1. So we can conclude and say that this geometric series is indeed convergent, right? It is convergent because the common ratio is in between 1 and minus 1. 2.1.2. Calculate the sum to infinity of this series. Let's go ahead and do that. The sum to infinity by definition is equals to a divided by 1 minus r. The question you might be asking yourself is, what is this a that we're talking about? It is the first term, which in our geometric series is 1 divided by 5. So we're going to have 1 divided by 5 divided by 1 minus the common ratio, which we know to be 1 divided by 3 at this point. So we're going to have 1 divided by 3. And then if you put that in your calculator, you should get 3 divided by 10. So this is the sum to infinity of our series. Now, moving on to the more interesting question, 2.2 and 2.2.1. So an arithmetic and a geometric sequence are combined to form the pattern, which is given by Pn is equals to x, 1 divided by 3, 2x, and so on. The first question says that let's write down the next two terms of this pattern. So let's just copy it down first. The first term, that is x, and then we have 1 divided by 3, we have 2x, 1 divided by 9, 3x, and 1 divided by 27. So the first term is x, and then the third term is 2x, right? And then the fifth term is 3x. That is our arithmetic sequence. And then on the other hand, we have 1 divided by 3, and then 1 divided by 9, and 1 divided by 27. That is our geometric sequence. So the term that is coming next here in our sequence, it is the term in the arithmetic sequence, right? So after 3x, we should have 4x, right? So in this position here, we're going to have 4x. We're going to have 4x. And then after 4x, we're going to have a term in the geometric sequence, which will be 1 divided by 81. 2.2.2 determine the general term Tn for the odd terms of this pattern. Write down your answer in terms of x. So the odd terms is the arithmetic, right? So we know that we have Tn is equals to a plus n minus 1 multiplied by d. So let's go ahead and find the difference. That is T2 minus T1. And then in the arithmetic sequence, T1 is x, right? And then T2 is 2x. So we're going to have the difference being equals to 2x minus x, which is just equals to x, right? And then, so now we have D. What about A? A is the first term. That is x, right? So we can substitute in our equation. Tn is going to be equals to x plus n minus 1 multiplied by the difference, which is also x. So we're going to have x plus xn minus x, right? So Tn is just equals to xn. That is the general term for the odd terms of this pattern in terms of x. 2.2.3, calculate the value of P26. 26 is an even number, right? So we must go to our pattern now and see which sequence. Is it the arithmetic or is it the geometric that lies on the even numbers of our pattern? You can see that the arithmetic is on the odd positions, right? And then the geometric is on the even positions. So in position 26, we are going to have a term on the geometric sequence. Although the term is in position 26, in our geometric sequence, it will be in position 13, because the other 13 position are filled out by the arithmetic sequence. Tn is equals to ar to the n minus 1, right? This is how you find the term on a geometric sequence. So a is the first term, obviously, that is 1 divided by 3. And then r is also 1 divided by 3, the common ratio which we calculated above, to the power n minus 1. So we're looking for position 26 on our sequence, which is position 13 on our geometric pattern. So we're going to have 13 minus 1. 1 divided by 1594323. The last question, 2.2.4, actually the difficult question. If the sum of Pn from n is equals to 1 to n is equals to 21 is equals to 33.5, determine the value of x. So you have to realize something here. You have to realize that the sum of Pn is equals to the sum of the even plus the sum of the odd. We know fully well that the terms on the odd positions are given by the arithmetic sequence, and the terms on the even positions are given by the geometric sequence. The sum is 33.5, which is equals to. Let me show you something first. We're looking for the sum of the first 21 terms. So in 21 terms, 10 terms will be even and 11 terms will be odd. The value of n here will be equals to 10 and the value of n here will be equals to 11 to ultimately give us 21, right? So let's just keep that in mind. So the sum of the even will be equals to, just a reminder, Sn is equals to a multiplied by r to the n minus 1 divided by r minus 1. This is for a geometric sequence, right, or geometric series, so to say. And then the sum for an arithmetic series, that is n divided by 2 multiplied by 2a plus n minus 1 multiplied by d. So let's just put this down here because we are going to use it, right? So the sum of the even, so the first term, that is 1 divided by 3, right? And then the ratio, we know that it is 1 divided by 3 also. And then to the power 10 minus 1 minus 1, right? Everything divided by r minus 1. So we have 1 divided by 3 minus 1 plus the sum of the odd. So let's just compute that real quick. So we're gonna get 33.5 being equals to 0.5 plus the sum of the odd, right? So if you take 0.5 to the other side, you're gonna get 33 being equals to the sum of the terms in the odd positions. We're gonna have 33 being equals to n divided by 2, right? So that will be 11 divided by 2 multiplied by 2a. So we have 2a is the first term, so that is x, and then plus n 11, right? Minus 1 multiplied by x again. So let's multiply out by 2 so that we can get rid of that denominator there. If we do that, we're gonna have 66 being equals to 11 multiplied by 2x plus 11x minus x, right? So if we divide both sides by 11, we're gonna get 6 being equals to 12x. So x is equals to 1 divided by 2. In order to answer this question, I actually had to go back and watch an introduction to quadratic sequences that I had made in the past, right? But then don't worry about that. I'm going to leave the link to that video in the description so that you can understand some of the things I'm going to be doing in this question, right? So it is saying that a quadratic sequence has the following properties. The second difference is 10. The first two terms are equal to each other, right? That is T1 is equals to T2. And then T1 plus T2 plus T3 will give you 28. Alright, and then the first equation 3.1 is saying, let's show that the general term of the sequence is Tn is equals to 5n squared minus 15n plus 16. Right, so we're given the second difference. It is said to be equals to 10, right? So that is a good start. Why am I saying that? We know fully well that 2a is equals to the second difference. 2a is equals to the second difference. Why is that important to us? Under normal circumstances, a quadratic sequence has the following format. Tn is equals to an squared plus bn plus c. So essentially what we're trying to do, we're trying to find the value of a, the value of b, and the value of c. If we do that, then we are supposed to have 5n squared minus 15n plus 16, right? So we have said that 2a is equals to the second difference. How much is the second difference? That is 10, right? So it should be easy to see here that a is equals to 5. And just like that, we already have 5, which is part of what we're trying to prove, right? So we are sort of convinced that we are on the correct route, right? And then the other thing we know about quadratic sequences is that 3a plus b is equals to t2 minus t1, right? And then we have established what a is equals to. So we have 3 multiplied by 5 plus b being equals to 0. Why are we saying t2 minus t1 is equals to 0? That is because we are told that t1 is equals to t2, right? So t2 minus t1 should be equals to 0. And then from there on, we're going to have b being equals to minus 15. We're just taking this term to the right hand side. And then that is exactly what we have in our equation, minus 15. So what is left? What more do we need to do? We just need to find the value of c, right? Which is going to be a bit tricky, but we're going to use the third bullet point that says t1 plus t2 plus t3 is equals to 28. So let's go ahead and see how we can do that. So we have t1 plus t2 plus t3 being equals to 28, right? So t1 of a quadratic sequence will be equals to a plus b plus c, right? That is T1. You can see why that is the case from the introduction video I'm talking about, which I'm going to leave in the comment. So you should probably watch it. And then plus T2. T2 is going to be 4A plus 2B plus C. If you cannot see what is going on, it's probably time you go and actually watch that video. And then T3, we're going to have 9A plus 3B plus C being equals to 28. Right. So what is the value of A? A is 5. So we're going to have 5 plus B, which is minus 15, right? So we're going to have 5 minus 15 plus C, right? That is for T1. And then for T2, we're going to have A is 5. So 4 multiplied by 5, that is 20. And then B is minus 15, right? So 2 multiplied by minus 15, so 20 minus 30 plus C. And then plus, now we at T3, right? 9 multiplied by, so now we have 9 multiplied by A, which is equals to 5. So we're going to get 45. And then plus 3 multiplied by B, so that is 3 multiplied by minus 15, which is minus 45, right? And then plus C is equals to 28. So let's see, we have plus C plus C plus C. So we're supposed to have 3C. Now we just need to add all the other constants, right? And when we do that, we get minus 20, right? And this is equals to 28. So we're gonna have 3C being equals to 28 plus 20, which is 48. And then we divide by 3 on both sides to get C is equals to positive 16. Right, so we have deduced that A is equals to 5, B is equals to minus 15, and C is equals to 16, right? So we have Tn being equals to 5n squared minus 15n plus 16, which is what we are required to prove. So we're good to go now. Let's do 3.2. So 3.2, the question is saying that is 216 a term in this sequence? Justify your answer with the necessary calculations. Right, so again, we know that Tn is equals to 5n squared minus 15n plus 16. Let's see if 216 is a term in this sequence. So in place of Tn, we're going to put 216. This will be equals to 5n squared minus 15n plus 16. Right, so if we can solve here and get a value of n, which is the whole number, then 216 is a term in this sequence. Right, so if we take 216 to the other side, we're going to have 5n squared minus 15n, not 18n, minus 15n, then plus 16 minus 216, that will be minus 200 being equals to 0. Right? It's easy to see here that we can take a common factor of 5 real quick and then divide both sides by 5 to get n squared minus 3n minus 50 being equals to 0. Right, so let's go ahead and try and factorize this. So we're going to have n, another bracket, we have n being equals to 0. We are not able to factorize this without using the quadratic formula. And as a consequence, 216 is not a term in this sequence. Is P an increasing or decreasing function? So that is 4.1.1, right? We have P of x, which is equals to 1 divided by 3 to the power x. So let's go ahead and find out whether this function is increasing or decreasing. How are we going to possibly do that? Let's start by substituting x is equals to 1 and see what we get. So if you substitute x is equals to 1 into p of x, you're going to get 1 divided by 3, right? And then if you substitute x is equals to 2, you're going to get p of 2 being equals to 1 divided by 9. And then if you substitute x is equals to 3, you're going to get p of 3 being equals to 1 divided by 27. Now it's actually easy to see that when the values of x are increasing, the values of y are decreasing, right? When x is equals to 1, we have 1 divided by 3. When x is equals to 2, we have 1 divided by 9. And then when x is equals to 3, we have 1 divided by 27. We can see from that test that our function is decreasing, right? Yeah, as the values of x increase, the values of y decrease. And then 4.1.2, determine p inverse, the inverse of p in the form y is equals to. So we have p of x being equals to 1 divided by 3 to the power of x. Instead of p of x, let's just put y in there. So we have y being equals to 1 divided by 3 to the power x. So when you want to find the inverse, the first thing you want to do is to swap x and y, right? So if we go ahead and do that, we're going to have x in place of y, right? And then in place of x, we now put y, right? And then from there on, all you just need to do is solve for y. Solve for y. As soon as you solve for y, then you're gonna have the function you're looking for. So how are we gonna possibly do that, right? Y is up here. We have to bring it down by introducing log on both sides, right? So we're gonna have log of x being equals to log of 1 divided by 3 to the y. Now you just have to recall that under log loss, log of a to the b is equals to b multiplied by log of a. So if we just apply that idea right here, we're gonna have log of x being equals to y log of 1 divided by 3. So we can go ahead and divide both sides by log of 1 divided by 3 in attempt to isolate y, right? And then if we do that, we're gonna end up having y is equals to log of x base 1 divided by 3. And that is the inverse of p of x. The following equation 4.1.3, let's write down the domain of p inverse. What I want you to know is that the domain of f inverse is equals to the range of f, right? So we're looking for the domain of p inverse. So actually we can find the domain of p inverse by just finding the range of p, right? And then for our function p of x is equals to 1 divided by 3 to the x. You can see that the range is going to be y is greater than 0. We are saying that to say that the domain of p inverse will be, so now we have the domain x is greater than 0, right? And then the last equation 4.1.4, write down the equation of the asymptote of p of x minus 5. So for any exponential function in the form a b to the x plus q, this q here will always be your asymptote, right? So let's go ahead and see what we're going to have for p of x minus 5. This will be equals to 1 divided by 3 to the power x minus 5. It's easy to see that in this function, our q is actually minus 5. So our asymptote is that y is equals to minus 5. Given that f of x is equals to 4 divided by x minus 1 plus 2, write down the equations of the asymptotes of f. That is 4.2 2.1. So you can see just from how the function looks that we have a hyperbola, right? One of the asymptotes will be at y is equals to 2, this value here, right? So we're gonna have our horizontal asymptote. So we have our horizontal asymptote being at y is equals to 2. Now what we need is our vertical asymptote. Our vertical asymptote will be at this denominator equals to 0, right? Because we know that we cannot divide by 0. So if you equate the denominator to 0, you're gonna find an x value for which the graph never touches, right? So if we go ahead and do that, we're gonna have x minus 1 is equals to 0, and then x is simply equals to 1, right? That is easy to see. So we have our horizontal asymptote and we have our vertical asymptote, that is 4.2.1, right? The value that is in here, this value right here, will always be your horizontal asymptote. If it was minus 3, then our horizontal asymptote would be minus 3, right? That's how it works. And then now moving to 4.2.2, the question is saying that let's calculate the x-intercept of f. We're looking for the x-intercept of f. As soon as I hear x-intercept, so we have x-intercept, I'm thinking y is equals to 0, right? So if we let y be equals to 0 in our function, we're going to have 0 being equals to 4 divided by x minus 1 plus 2. What we want to do when we have something like this is to subtract 2 from both sides, right? To get minus 2 is equals to 4 divided by x minus 1. And then if we cross multiply, we're going to get minus 2x plus 2 is equals to 4. Minus 2x will be equals to 2, and then x will be equals to minus 1. So the coordinate for our x-intercept, right, we have minus 1 and 0, right? And then now 4.2.3, we are required to sketch the graph of f and label all asymptotes and indicate the intercepts with the x's. So in 4.2.2, we only calculated the x-intercept, but then now we are required to indicate the intercepts, right? So we need to find the y-intercept. So y-intercept x is equals to 0. So let's go ahead and find the y-intercept so that we can be able to sketch our graph and indicate all that we are required to, right? So we're gonna have y being equals to 4 divided by, now x is 0, right? Minus 1 plus 2. So we're gonna have 4 divided by minus 1 plus 2. This is minus 4 plus 2. This is equals to minus 2, right? So the coordinate for our y-intercept, we have x being equals to 0 and y being minus 2, right? So now we have the asymptotes, we have the intercepts, we can sketch our graph. Let's go ahead and do that. So we need our x's, obviously, right? We cannot have it any other way. So there goes our y-axis and there goes our x-axis. So the first thing we want to do is to put our asymptotes first, right? So let's just say this is 1, 2, 3. And then this can be minus 1, minus 2, minus 3. And then again for the y-axis, 1, 2, 3, minus 1, minus 2, and minus 3. So right, so let's go ahead and put our asymptotes in our graph, right? We have a horizontal asymptote at y is equals to 2. So let's just go ahead and have that there. So there goes our horizontal asymptote. And then our vertical asymptote is at x is equals to 1, right? So let's do likewise. There goes our vertical asymptote, right? Now we just need to indicate the intercepts. We have one intercept at -1 and 0, right? The x-intercept. So we're going to have a coordinate right here at -1 and 0. And then the other one is at 0 and -2. So we have another intercept here. And just like that, we're almost done. We just need to sketch our function, right? If we go ahead and do that, we should have something like this. So our graph should go through our intercepts, obviously, right? And then, yeah, that is one part of our function. And the other part of our function will lie in the first quadrant, right? Right, there we go. We're supposed to have something like that. We've indicated our asymptotes. We've indicated our intercepts. I think we're good to go, right? Let's do 2.4. So 2.4, using our graph, let's determine the values of x for which 4 divided by x minus 1 is greater or equals to -2, right? If we take -2 to the other side, we're going to have 4 divided by x minus 1 plus 2 is greater or equals to 0, right? So what we're actually looking for here, we're looking for the values of x for which our function f of x is greater or equals to 0, right? Because this is simply f of x if you look at it. Right, so let's go to our function and look for the values of x for which our function is greater than or equals to 0, right? We can see that for this entire part of the function, it is greater than 0, right? And then here from -1, if we go to that side, our function will be greater than 0, right? So part of our solution, we have x being greater than 1, right? When x is greater than 1, our function is clearly greater than 0, right? And then when x is less or equals to -1, our function is also greater than, yeah, it's greater than 0. It's greater than 0. It's greater or equals to. So here we can put in this equals to, right? It's not going to cause us any issues because our function is defined at x is equals to -1. But then here we cannot have an equals to because our function is not defined when x is equals to 1, right? So we're supposed to say x greater than 1, right? And then the last question, 4.2.5. Let's determine the equation of the axis of symmetry of f of x minus 2 that has a negative gradient. So what is this f of x minus 2? Let's figure it out. So we know that f of x is equals to 4 divided by x minus 1 plus 2. So f of x minus 2. So in place of x, we're now going to have x minus 2 and then minus 1 plus 2. Right, and then this will be equals to 4 divided by x minus 3 plus 2. Right, so this is what they're talking about when they say f of x minus 2. So we need the equation of the axis of symmetry that has a negative gradient. So we have two axes of symmetry, one with a negative gradient and then one with a positive gradient. So the one with the negative gradient, y is equals to minus x plus c, negative gradient. And then the one with the positive gradient, we have y is equals to x plus c. So what you're required to do actually is to just find the value of c, right? And then you have your axis of symmetry. So which point did you substitute if you want to find the value of c in your axis of symmetry? You substitute the point where your asymptotes touch. So now we actually have to find the asymptote of f of x minus 2. Let's go ahead and do that. We know that 2 will be our horizontal asymptote. Now we just need to find our vertical asymptote by saying that x minus 3 is equals to 0, right? Now you're going to see that x is equals to 3 is our vertical asymptote. So they're going to touch when x is equals to 3 and y is equals to 2. Now we just need to substitute that in our equation for the axis of symmetry with the negative gradient, right? So if we go ahead and do that, y is 2, right? And then minus x is 3 plus c, right? So if we take minus 3 to the other side, the way you would say it, we would have 5 is equals to c, right? And then now we have y is equals to minus x plus 5 being the equation of our axis of symmetry of f of x minus 2. Write down the coordinates of the turning point of f. So f of x is equals to minus x plus 3 to the power 2 plus 4, right? So the coordinates of the turning point of this function will be minus 3 and 4, right? We can clearly see that in our equation. But then for most people, it's a bit confusing when the equation is like this. They like to solve it first and then use x is equals to minus b divided by 2a. So if we do that, we're going to have f of x being equals to minus x squared plus 6x plus 9. That's what you get when you solve x plus 3 to the power 2 and then plus 4, right? So we're going to have minus x squared minus 6x minus 9 plus 4. So this is equals to minus x squared minus 6x minus 5, right? If you say x is equals to minus b divided by 2a, you're going to get minus 6 divided by 2 minus 1, right? Which is equals to minus 3. And then if you substitute minus 3 into f of x, you're going to get 4. So indeed, the coordinates of our turning point, we have minus 3 and 4, right? But this is the equation of f of x, right? We're going to need this equation as time goes. So let's just keep it there because we're gonna need it soon, right? And then 5.2, write down the range of f. So let's look at our function here. So we've already established that the y value here at the turning point is 4, right? And we can see that our graph never goes above 4. It just touches there at 4 and then it goes infinitely down, so to say, right? So we can say that y is less or equals to 4, right? For all the values of x, y is either 4 or less than that. All right, so that is the range of our function f. And then 5.3, this is where things start to get interesting. Show that the x coordinates of a and b are minus 5 and 2. So we say that f of x is equals to, so we have our function here, minus x squared minus 6x minus 5, right? So if we want to find the x coordinate of a and b, what we have to do is equate f of x, our parabola, right, and g of x, our straight line. So the equation of our straight line, we have g of x is equals to x plus 5. So if we equate those two, we're gonna get minus x squared minus 6x minus 5 is equals to x plus 5. Right, so we're gonna have minus x squared. We take in x to the left hand side, we're gonna get minus 5x, and then plus 5 is gonna be minus 5, right? So we have not minus 5 but minus 7, right? So we're gonna have minus 7x, and then minus 10 is equals to 0, right? Just one mistake and you're gone, right? So I have minus x squared here, which is, confusing me a bit. So I'm just going to multiply everything by minus 1, right? So that I can have x squared plus 7x plus 10 is equals to 0. Now it looks clean. I can go ahead and factorize. So I'm going to have that there. And then now the equation I'm asking myself, which two numbers do I multiply and get 10? And then when I add, I get plus 7. That is 5 and 2. So when I have x plus 5 and x plus 2. So it's easy to see now that x is equal to minus 5 or x is equal to minus 2. And then this is the x value of A and this is the x value of B. It's quite straightforward. There isn't really anything complicated in this one, right? Unlike 5.4 and 5.5. So let's look at 5.5. So 5.5 is saying that hence determine the values of C for which minus x plus c plus 3 squared plus 4 is equals to x plus c plus 5 has one negative and one positive root. At this point, our roots are at, let me just change the color real quick, at minus 5 and minus 2, right? That's where our roots are at the moment, based on 5.4. So now we need to shift our graph. Let's not forget that x plus something is shifting our graph, right? So let's shift our graph such that now one root is negative and then another root is positive, right? So if we have minus 2 here at B, we need to shift our graph just above 2 units to the right, just above 2 units to the right. Then one root is going to be slightly greater than 0 and the other one is still going to be less than 0, right? So that's what we want to do. So another thing to remember here is that if you have x plus 2, you are shifting your graph 2 units to the left, right? You're shifting your graph 2 units to the left. But then if you have x minus 2, you're shifting it 2 units to the right. I know it's counterintuitive that the plus is to the left and minus is to the right in this case, but that's what it is, right? So we need C to be just slightly greater than minus 2 so that we can shift our graph just more than 2 units to the right. So if C is just slightly greater than minus 2, then our problem is solved. We're going to have one negative and one positive root, right? I'm interested in how you guys interpreted this equation. Can you please just let me know in the comments if you don't mind? I would really appreciate that, right? 5.6 5.6 is saying that the maximum distance between f and g in the interval x of a and x of b. So yeah, in this interval, let me just erase this so that we can have a bit of clarity, right? Let me just put that there real quick, right? So this is the interval we're interested in. This is the interval we are interested in, right? So the question is saying the maximum distance between f and g in that interval is k, the maximum distance. If h of x is equals to g of x plus k, determine the equation of h in the form h is equals to. So we already have g of x, right? So to determine the equation of h of x, we just need the value of k. And then we are told that k is the maximum distance between f and g in that interval, right? So let's just go ahead and try find the maximum distance between f and g in that interval, right? So how do you find maximum distance? You say the graph on top minus the graph at the bottom is equals to 0, right? And then after that, you're going to derivate the result and equate to 0. Let me show you what I'm talking about before I just confuse you. So we have f of x minus g of x, right? That is how you find the equation for the distance between the two graphs. So f of x minus g of x will be equals to, what's our equation for f of x again? Where is it? Here it is. So we have minus x squared minus 6x minus 5. And then we're subtracting g of x, which is x plus 5. Right, we're trying to find an equation for the distance between the two graphs. Right, so we're gonna have minus x squared minus 7x minus 10. So this is the equation for the distance between the two graphs. So if we want to find the maximum distance, we have to derivate this equation and equate it to 0. Right, so if we say distance, the derivative of the function for the distance is equals to 0, then we're gonna have minus 2x. We can just use the power rule, right? Minus 7 is equals to 0. So we're gonna have minus 2x being equals to 7. Right, so x is clearly equals to minus 7 divided by 2. So let me just put minus 7 divided by 2 in the calculator. It's minus 3.5, right? And minus 3.5 is between minus 5 and minus 2. So right, that is the x value for which the distance between the two functions is at a maximum. Right, now we just need to find the distance by equating this answer into this equation, right? And then that will be the value of k, and we're gonna consequently have the function h of x. So if we sub x into that equation, we're gonna have minus 7 divided by 2 squared minus 7 divided by 2 minus 10. Right, so that is our maximum distance. So let me just put that in my calculator and see what I'm getting. So minus 10, and I'm getting 2.25. I'm getting 2.25 units, right? So the value of k is 2.25 based on what I'm proposing here. So now we can go ahead and say that h of x is equals to g of x, which is x plus 5, and then plus k, which is 2.25. Right, so we have x, and then what's 5 plus 2.25? That is plus 7.25. What I usually do before using first principles is using the power rule, so that when I get my answer after using the first principles, I can see if my answer is correct or not. So what do we have here? We have f of x, which is equals to minus 2x squared minus 1. So if we derivate this using the power rule, right, we're going to get minus 4x. Right, so now we can go ahead and use the first principle. We are doing 7.1, by the way. And then if we don't get minus 4x as our final answer, we know that we've made a mistake somewhere. So let's go ahead and solve this equation so that we can see what we have here. 7.1, so we're going to say f prime of x is equals to the limit as h tends to 0 of f of x plus h minus f of x, everything divided by h. Right, so this will be equals to the limit as h turns into 0, and then here we have f of x plus h. Right, so we're writing the equation of f of x, but then everywhere where we have x, we put x plus h instead. It's that simple. Let me show you how it will look like. So we have minus 2x squared. So instead of x, we're gonna put x plus h. Right, and then we square that, and then we have our minus 1 right there. So we are done with the first part. And then the second part, we're just subtracting f of x as it is, right? So if we do that, we're going to have minus 2x squared minus 1. And then we're going to divide everything by h. This is how you do derivation using the first principle. Now we just have to do a bit of algebra. Let's go ahead and do that. So we're gonna have the limit as h tends to 0 of, so we have minus 2, and then x multiplied by x, that is x squared. X multiplied by h is xh. You multiply that by 2, you get plus 2xh, and then h multiplied by h, that's h squared, right? And then we have minus 1, and then minus multiplied by minus, that will give us plus 2x squared, and then minus multiplied by minus again, that will give us plus 1, and then everything divided by h, right? We still have our limit as h tends to 0, right? So now we just multiplying out by minus 2, right? Let's go ahead and do that. We're gonna have minus 2x squared minus 4xh minus 2h squared, and then minus 1. Let's not forget this minus 1, which is out here, and then plus 2x squared plus 1. We're dividing everything by h. Now I want to show you something. We have minus 2x squared here plus 2x squared, and then we have minus 1 plus 1. So we're only left with minus 4xh and minus 2h squared. So we're gonna have the limit as h tends to 0 of minus 4xh minus 2h squared divided by h. So the limit as h tends to 0. So let's take h as a common factor in the numerator. If we do that, we're gonna have f h, not f, and then multiply by minus 4x minus 2h divided by h. H and h cancel out. Now we have minus 4x minus 2, h is turning to 0, right? So this is just minus 4x, and then you can see now that we have the same answer when we use the first principle and when we use the power rule. So now we are convinced that what we did is correct, right? 7.2. The interesting question here is 7.3. That's the interesting question. Let's just do 7.2 first, and then we're gonna move to that. 7.2.1. We have f of x, which is equals to minus 2x to the 3 plus 3x squared. We want the derivative using, we're not told what to use, right? So we can just use the power rule, the faster method, right? So if we say f prime of x, we're gonna get, so the base, not the base, but the exponent, multiply the base, and then we subtract 1, right? So minus 2 multiplied by 3, that will be minus 6, and then x to the power 3 minus 1, which is 2. Then the same thing, 2 multiplied 3, we get 6, and then x, we subtract 1 from the power. So we just have x to the power of 1, right? So that is our answer for 7.2.1, minus 6x squared plus 6x. Right, that checks out. Let's do 7.2.2. So here we're looking for dy over dx when y is equals to 2x plus 1 divided by square root of 4x, right? So we're still trying to derivate here, but then you see we have an issue. We cannot really use a power rule when it's like this. It's a bit confusing, you know. So let me make it linear and get rid of the square root so that I can easily use the power rule. It's a bit confusing for me. I don't know about you, right? So if we do that, we're gonna get 2x plus, and then instead of writing it as 1 divided by square root of 4x, I'm gonna write it as square root of 4x everything to the power minus 1. It is the same thing, right? And then we're gonna have 2x plus. So instead of writing square root of 4x, I'm gonna write 4x to the power half. That's the same thing as having the square root, right? And then this is all to the power minus 1. So 2x plus, and then we're gonna have a half multiplied by minus 1, right? So that will be 4x to the power minus a half. So if we solve that, we're gonna get 2x and then 4x to the power minus a half. So we have 4 to the power minus a half. I'm getting 1 divided by 2. So I have plus 1 divided by 2, and then x to the power minus 1 divided by 2. Right, so now we can then use the power rule. Yeah, we can only use the power rule at this point. If we use the power rule for 2x, we're just going to be left with 2. And then now we multiply the coefficient by the exponent. We're going to get minus 1 divided by 4x, and then we're supposed to subtract 1 here. If we do that, we're going to get minus 3 divided by 2. And this is almost our final answer. It's not, right? We have to get rid of this minus 3 divided by 2. Yeah, we have to get rid of that. You know, when we found our equation, it didn't have any minus exponent. So let's be kind and take it back to the form found it in, right? So if we do that, we're gonna have 2, and then we can have minus 1 divided by 4, and then x to the power 3 divided by 2. Right, we are allowed to say that. Now it looks a whole lot better, right? 7.3 is saying that the graph of y is equals to f prime of x has the minimum turning point at 1 for the x value and minus 3 for the y value. Determine the values of x for which f is concave down. Right, so to find the values of x for which a function is concave up or concave down, we have to look for the point of inflection, right? So if we have f of x and your graph is cubic, when you find f prime of x, your graph is parabolic. Right, and then at the turning point of that parabolic function, that's where you have your point of inflection. And then here we given the x value at the turning point. You can see right here we given the x value at the turning point. It is said to be equals to 1. Right, so now the question I'm asking you is, our answer supposed to be x greater than 1 or x less than 1? Can you please just let me know in the comments and why you're saying so? Write down the y-intercept of f. Right, so as soon as I hear y-intercept, I'm thinking x is equals to 0. Right, so let's go ahead and substitute x is equals to 0 into f of x. So if you substitute 0 into f of x, you're gonna get 0 to the 3 plus 4 multiplied by 0 to the 2 minus 7 multiplied by 0 minus 10. It's easy here to see that your answer is going to be equals to minus 10, right? So that is the y-intercept of f. Y is equals to minus 10, right? We have some coordinate of which the x is 0 and the y is minus 10. Right, that is 8.1. Let's go ahead and do 8.2. So in 8.2, we are required to show that 2 is a root of the equation f of x. Right, if 2 is indeed the root of the equation f of x, then when we substitute 2 into f of x, we shall get f of x is equals to 0. Right, so let's go ahead and see if that checks out, right? So we're going to have f of 2 is equals to 2 to the power 3. The question is saying that let's show that. So we already know that it is supposed to be true, right? But then we still need to write it down so that we can actually show that. And then plus 4 multiplied by 2 to the power 2 minus 7 multiplied by 2 minus 10, right? And then if you put that in your calculator, you should get f when x is equals to 2 will give you 0, right? So that is the root of our equation f of x, right? Moving to 8.3. 8.3 is saying that let's hence factorize f of x completely, right? So we're going to have something that looks like the following. F of x is equals to x, and then we know that 2 is a root of our equation, right? So we're going to have x minus 2 multiplied by some function here, right? We're supposed to multiply x minus 2 by a quadratic function, right? So let me show you something. Here we have x to the power 3, right? We already have x here. So it would make sense to say that we need x to the power of 2 there, so that when x multiplies x to the power of 2, we're going to have x to the power of 3. Now, let me show you something. Also, we have minus 2 here, and then in our function, we have minus 10. So what do you need to multiply minus 2 with so that you can get minus 10? That is plus 5. So we have plus 5 right there. Right, now we just need the middle term of our quadratic function. Right, let me show you how we're going to get that. So when we multiply minus 2 by x squared, right, we're gonna get minus 2x squared. But then in our equation here, we have plus 4x squared. You can see that we have plus 4x squared here, right? So we need to add something into minus 2x squared such that we get 4x squared. What do we need to add there? It's easy to see that you need to add 6x squared, right? So that you can get 4x squared, right? So here we're gonna have plus 6x, not plus 6x squared, plus 6x. We're gonna get 6x squared from multiplying x and 6x, right? So this is how you can factorize a cubic function. But then our question is very specific. It says that we need to factorize it completely, right? So we also need to now come and factorize that function that we have there, right? So f of x will be equals to x minus 2 multiplied by, we can open 2 brackets now. So when we're factorizing a function like this, we're looking for two numbers that when we multiply we get 5, and then when we add we get 6. That is easy to see, right? That will be plus 5 and plus 1. So we're gonna have x plus 5 multiplied by x plus 1, and just like that we have factorized our cubic function completely, right? Let's move to 8.4. Let's move to 8.4. It is if it is further given that the coordinates of the turning points are approximately at this coordinate here and this coordinate here, draw a sketch graph of f and label all the intercepts and turning points, right? So when we factorize, we end up with our x-intercept, right? X is equals to 2, x is equals to minus 5, and x is equals to minus 1. And we know the y-intercept from 8.1. So the intercepts, we have those covered. And then we are given the turning points, right? So we have all we need. We just need to sketch our function. So let's go ahead and do that, right? So let's, let me draw the set of x's. So we can have our x here, and we can have our y here, right? Let's see what we get. So let's start with the y-intercept. We know that it is at minus 10, so we are interested at this point. Let me just take it a bit down. So we have minus 10 here, and then let's go to the x-intercept. We have one at minus 5, and then we have another one at minus 1, and we have another one at 2, right? So those are our intercepts. Now we need the turning points. We have this first one here, which says 0.7 and minus 12.6, right? So let's have minus 12.6 here, and then 0.7. We can put it somewhere here, right? That makes sense. And then minus 3.4, supposed to be between -5 and -1, right? And then this one, it has a y coordinate of 20.8. So let's have 20.8 here. Yeah, so this is a coordinate. This is a coordinate. And then 0.7 and 12.6. We have another coordinate there. So now we need to go ahead and sketch our cubic function. Right. As you can see here, we have x to the power 3, right? So our graph should start being concave down until it changes concavity and becomes a concave up. Right. So let me sketch that so that you can see what I'm talking about. So our turning point is here. We have one turning point here, right? And then we need an intercept there. And then another intercept is here. From here, we need to go to -10, right? And then 10 at -12.6. And then go up and go through x is equals to 2, right? So our function is supposed to look like that. That is how our function is supposed to look like. So we have the y-axis here, and then we have the x-axis here. So right, that is 8.1. I'm pretty much sure we got the same thing. And 8.5.1. Let's determine the values of x for which f prime of x is less than 0. Right. So what is f prime of x? F prime of x is the gradient of our function, right? So we need to find the values for which our gradient is negative. The gradient is a negative when our graph is sloping down, right? So we can see that it is sloping down in between our turning points. Right here, that is where, let me just use a different color. So right here, this is where our graph is sloping down, right? So f prime of x is less than 0 in that interval. So when x is between what? 0.7 and -3.4, yeah, that is where our gradient is negative, right? The last question, 8.5.3, we're looking for values of x for which f prime of x multiplied by f, and then the prime of x, or the second derivative of our equation, is less or equals to 0. I'm very much interested in how you guys solved this question. Can you please just let me know in the comments? A wire 12 meters long is cut into 2 pieces. One part is bent to form an equilateral triangle and the other a square. A side of the triangle has a length of 2x meters. Right, so that is the information we have. Let's go ahead and conceptualize so that we can have a bit of clarity. Right, so let's start with the equilateral triangle, right? So let's see our triangle looks something like this, right? And then if this triangle is indeed equilateral, then all the 3 sides should be equal to each other, right? And then we are given the side of the triangle is said to be 2x meters, right? So now we can say that this side here is 2x, this side is also 2x, and this side is also 2x, right? So if you add up all those sizes, you're gonna get 6x, right? That is the amount of wire used to make that triangle, right? And then now from the piece of wire that is remaining, or the other piece, it is used to form a square, right? So let's go ahead and have a square. So from the 12 meters, we have already lost 6x meters, right? So we can say 12 minus 6x. So this is the amount of wire that is used to construct the square. Now we can clearly see that one side of the square will be 12 minus 6x divided by 4. The other one will be 12 minus 6x divided by 4. 12 minus 6x divided by 4. And lastly, 12 minus 6x divided by 4. If you add all those, you get 12 minus 6x. Right, so now we have a bit of clarity. We can finally start answering our questions. So let's look at 9.1. So 9.1 is saying that let's write down the length of a side of the square in terms of x. Right, so we have already deduced that the length of the sides of the square will be 12 minus 6x divided by 4. Right, so that is 9.1. And now the interesting question, 9.2. It is saying that if this square is now used as the base of a rectangular prism with a height of 4x meters, determine the maximum volume of the rectangular prism. Right, so let me just sketch a rectangular prism first before we go on and solve this problem. So at the base, we have the square, right? So we need a square at the base, right? And then we have our heights there. And then, yeah, another square at the top, right? So the size of the square, we know fully well that we have 12 minus 6x divided by 4. Then the other side should also be 12 minus 6x divided by 4. And then the height is said to be 4x. Right. So the question is asking us to determine the maximum volume of the rectangular prism. So what are we going to do here? So what we're going to do, we're going to determine the volume of the rectangular prism. And then after determining the volume of the rectangular prism, it's going to be in terms of x, right? Because we have a variable. We're going to derivate this volume. And then when we derivate it, we're going to find the maximum and the minimum. And then we're going to take the maximum as the maximum volume of our rectangular prism. Let me show you what I'm talking about. So we're going to say that the volume is equals to the length multiplied by the width multiplied by the height. So this will be equals to, so the length we can clearly see here is 12 minus 6x divided by 4. So we're gonna have 12 minus 6x divided by 4 multiplied by the width, which is also 12 minus 6x divided by 4 multiplied by the height, which is 4x. Right, and now we have 12 minus 6x divided by 4 multiplied by 12 minus 6x divided by 4. That is just 12 minus 6x divided by 4, everything to the power 2 multiplied by 4x. Right, so this will be equals to, so if we have a divided by b, everything to the power 2, this is the same as a to the power 2 divided by b to the power 2, right? Grade 8 mathematics. So right, if we apply that there, we're gonna have, so let's start with the easy one. Let's start with 4 squared. 4 squared will give you 16. Now we can come to the numerator. In the numerator, we're gonna say 12 multiplied by 12. That will give us 144. And then we say 12 multiplied by minus 6x, that will give us minus 72x. You multiply that by 2 and you get minus 144x. And then plus minus 6x multiplied by minus 6x, that will be 36x squared, everything multiplied by 4x. Right, so what you can do here, you can actually solve this by taking the long road, right? Literally multiplying out the brackets. Yeah, but then, yeah, my method is a bit advanced now. I know how to do it without having to do that. Right, let's move forward and see what we have. So we can go ahead and multiply the entire numerator by 4x, right? Let's not forget that we have 4x there. So let's try multiply everything and see what we're gonna get. So if we see 144 multiplied by 4x, we're gonna get 576x minus, so that will also be 576, but then now we have x squared, right? And then plus 36 multiplied by 4, that is 144 x to the power 3, right? And then we're dividing everything by 16. If we go ahead and divide everything by 16, we're going to get 5,760 divided by 16, which is equals to 36x minus 36x squared in these in the middle term, right? And then the last term we have 144 divided by 36, or not 36 but 16 divided by 16. That will be plus 9x to the power 3, right? So this is our volume, right? So what we need to do now is to derivate this and equate to 0, right? So if we go ahead and derivate the volume, we're gonna get 9 multiplied by 3, which is, yeah, let me not start by derivation from this side. Let me start from this side. It's fine. I was starting from the other side. So if we derivate 36x, we're gonna get 36, and then if we derivate 36x squared, we're gonna get 72x, and then 9 multiplied by 3, we're derivating 9x to the power 3, we're gonna get 27x squared, right? So now we can equate that to 0, right? Let me write it nicely. So we're gonna have 27x squared minus 72x plus 36 is equals to 0. If we take 9 as a common factor, we're gonna have 3x squared minus 8x plus 4 is equals to 0, right? So we can divide both sides by 9 and just get 3x squared minus 8x plus 4 is equals to 0, right? So now we just need the x values for this quadratic function, right? It's a bit difficult for me to factorize it when it looks like this. I always resort to using the quadratic formula. So if I do that, I'm going to add x is equals to minus b plus or minus the square root of b squared minus 4ac divided by 2a, right? So minus 8 plus or minus, so I have b squared, that is minus 8 squared, minus 4ac. A is 3, c is 4, and then everything divided by 2 multiplied by 3, right? So let me just put this in my calculator real quick. So minus 8 squared minus 4 multiplied by 3 multiplied by 4, everything divided by 2 multiplied by 3. So I'm getting x is equals to 2, or x is equals to. So let me find out what the other value of x is. The other value of x is 2 divided by 3, right? So one between these two values is supposed to be a maximum, and the other one is supposed to be a minimum, and we're looking for the maximum. So let's go ahead and substitute x is equals to 2 and x is equals to 2 divided by 3 in our equation for the volume and see what we're gonna get, right? So the equation for the volume is right here. This is where we have the equation for our volume. So when we sub x is equals to 2, let's see what we're gonna have. So the volume is gonna be equals to, let me just put that in my calculator real quick and see what I have. 9, right? I'm getting 0 actually when I substitute x is equals to 2. Right, let me substitute x is equals to 2 divided by 3 and see what I get. So now I just need to divide all the 2's by 3, and I'm getting 10. I'm getting a volume of 10.6667 meters. Is it meters?